Okay, so it's live, I can start, right?
Yep.
Okay. You guys see this? Can you still see this?
Yes.
Okay, good. Okay, so I'm going to start with GDA internal review session 1. It's going to be one of 3 review sessions. So just to give a quick rundown of what we're going to go over. So just starting with the purpose of this internal review session, then moving on to some possibly contentious topics, which we can shelve until the questions at the very end. I didn't put questions, but we'll go over that. Then a brief overview of the architecture. It's pretty similar to the other agreements, so there's not too much to go over there. It's just more of a refresher for everyone. And then the features and functions of the GDA, and I'm going to be basically looking at how the IDA was compared to the GDA and using that as the base reference, so it's easy to compare some of the functionality here. And then a happy path example of how this would be used, and then going over the implementation based on that happy path example in the previous slide, I guess. And then lastly, time for some questions and stuff. So it's going to be an hour and a half until 2:30 or 3:30, depending on where you are. So the overall purpose of this is just to give an overview of the current implementation of the GDA. So the architecture, the features, how it's used, and an overview of the implementation, the actual code itself. And an opportunity also for everyone to chime in on whether anything in the API needs to be added, removed, or updated. Some possibly contentious topics that I'm personally aware of, which could be shelved until the end. The adjustment flow, API design, and also the NFTs itself. So just to quickly go over the architecture. So it's pretty similar to CFA and IDA. You basically register the agreement through the host. The GDA does some modifications to the super token contract storage. And the main difference is that there is an extra piece here. So there's a Superfluid pool. And this is a contract that's deployed whenever you create a pool. So in the IDA, you create an index, but that's all held internally in storage, in the super token storage. But in the GDA, there's a new contract that gets created, and it uses the beacon proxy pattern. So I can just go over each of these points. So firstly, the Superfluid pool and the GDA both leverage the semantic money library. So most of the logic in Superfluid pool and GDA are abstracted away into this library. So there's not too much of that in either GDA or the pool. So therefore, that means this GDA and Superfluid pool acts as an interface between the users and the super token. These two contracts basically handle the storage of data inside of the super token contracts. The agreement states of the specific super token is still saved in the super token, but we are using a new type of object. I didn't finish this, but it's called monetary units, I think. But there's some interfacing in these two contracts to make that work. So yeah, both of these, once again, use the semantic money library. So a lot of the logic, you're giving some inputs, but this library gives out the output, and all we're doing is taking the output and then saving it in the super token via the agreements or Superfluid pool. So actually, it's all done through the agreement, and that the access control is granted through the registration of the GDA through the host. And lastly, the more new thing other than semantic money is the beacon proxy pattern. So I chose to do beacon proxy because we're going to be creating, or anyone can create their own superfluid pool. And we possibly would want that whenever you update the superfluid pool logic, all of the proxy pools that are deployed out there to also be upgraded. We could also do the other approach of UUPX proxy, like the super tokens right now, but that would mean that some people might not get the newest, not have the newest logic contract, and it's a similar process as updating the super tokens. Any questions so far?
Could you repeat the last sentence, please?
Yeah, so we could use UUPX proxy, similar to the way that super tokens are done right now. But that would mean that when we were doing an upgrade of, let's say, the superfluid pool logic, if we ever do, we would have to upgrade them in a similar way. So you have to loop over everything and upgrade all of them. But in this case, you can just upgrade the logic contract that the beacon is pointing to. So the way that the beacon proxy pattern works is you have something called a beacon, and it points at a logic contract. And when you deploy a proxy, you pass this beacon in the proxy. So whenever you upgrade or update the superfluid pool logic contract and point this to a new logic contract, let's say, all of these will see that change.
Is it possible to later point a specific instance to a different one? Or is that road closed by using the beacon?
I think that road is closed by using the beacon, yeah.
But on the other hand, all the logic contract exists itself, right? The beacon is just one index, let's call it. Right? So if you really wish to use old one, you have to create your own the actual proxy, right? So the way I understand it, you have a bunch of logic contract you would deploy anyway, and then you have a beacon one, and then you can still create your own one to your own upgrade process, right? So you are not affected by the beacon.
Yeah.
But that's kind of, you have to do it yourself, right? So it's not.
You have to do yourself, and it won't work with the protocol.
But you have to already make that decision before the initial proxy deployment, right?
Yeah, exactly.
And not change your mind later on. Now I'm asking because there's now a case with a pure super token where we discussed to update the logic to custom to a different implementation of super token logic.
Okay.
So something like that wouldn't possible, I guess.
Yeah, but wait, let's not conflate two things. One is a super token related logic, which we do allow versioning,
Exactly,
customization, but CFA, IDA, GDA, all the agreements are tightly coupled, actually strictly coupled with host versions. You can't really have mismatch, right? So we don't guarantee any behavior. So from that, let's not conflate two things, I would say. So in that case, what I was saying was not really relevant because, basically has to be coupled together.
Yeah. So
go.
I had a question on back of that, because then my question would be, why would you want to deploy your own pool?
Yeah, that's the thing. I don't think we should allow people to have so much customizability with there. Like currently, it's just not allowed. We kind of want to reduce the amount of custom code that people can put that can interact with our agreements, right? So in this case, at least, that's why I think this pattern makes the most sense. I don't see why you would want to have your own pool logic either. I can't think of any reason. If you guys can think of something right now, or keep it in the back of your mind, and if there's a good reason, then we can design around that.
Yeah, it's about the extension point. We want to have a more extending the behavior for the pool, right? Adding hooks and all those stuff. But The whole point of
edit-
extension is that you can't think of how people use it. So you would
Mhm.
want to build it in, but of course adds to complexity and you should solve. But I think it's fine if we start without for now.
Yeah, I have the ideas for it, but I think it's good to not try to do all this in this iteration.
Mhm. Okay, I'm gonna continue. So I'll jump over the different features. They're basically functions, I guess. So starting with the admin functions, you have create pool, and the exact thing in IDA would be create index, I guess. So the difference is that a new contract is created for the pool, and the admin is set during creation, in the sense that you can choose who the admin of the pool is, whereas in the IDA, the message sender from the context is the admin of the index. And the admin is the individual that can both set update member units and also the receiver of the adjustment flow rate. Also, the pool admin NFT is minted when a pool is created, and it's never burned because you can't delete a pool. Similar to an index, you can't delete an index. You can also update member, which in the IDA is update subscription units. And the difference is mainly the usage of semantic money library here. Most of that logic is abstracted away to the library. You also can get a member NFT. So this is minted when greater than 0 units are granted to a member from the admin, and burned when units are removed. You can also transfer the units in the Superfluid pool because it's an ERC20 as well. So you can actually burn your own NFT, but if you transfer all of your units to someone else, and you can also mint NFTs for other individuals who don't currently
So
have NFT.
is it correct to say that update member is kind of a combination of no, it's a mint, basically, like a mint in ERC20, is that correct?
Yeah,
Because they're newly created.
it's a mint
Or
function. Yeah.
mint or burn, because I guess it could also be reduced. So it's
Yeah,
mint or burn.
it's mint or burn, and creating it out of thin air is only available to the admin, but as a member, you can transfer it around just like ERC20 itself.
Okay, so
Okay.
it's like mint or burn, but instead of the delta, you provide the absolute value. Okay.
Yeah, exactly.
Did we consider also providing mint and burn as actual API as functions, or do you think that would be confusing for units?
We don't currently have that, but that is something to consider for sure. I'm not sure if we can.
Should we already discuss the API naming now, or better wait for later?
We can do it later or now, up to you guys. I don't really mind, actually. Maybe it's better for later once you see the
the full picture. Okay.
So there's also member functions, so you can connect to a pool. This is the same thing as approving the subscription in IDA. You can disconnect pool, and this is the same as deleting the subscription, in the sense that you're deleting the agreement. So the main difference is that currently there's no equivalent to revoke subscription. What this just sets, which would be setting the connection status, but doesn't delete the agreement data. So in the IDA, we have approve, delete, and revoke. The delete actually deletes the agreement data completely. The revoke subscription just sets the is connected or approval status to false in IDA, but we only have one to create and then delete. Similarly, there is claim all, and the main difference is that it claims for the message sender calling the function, And we also have claim all passing in the member, and this is the same as the claim function in
Could
the
you,
IDA.
yeah, could you go back one slide?
Yep.
I was a bit confused. Create pool. What the function is?
Great. Well, in the GDA.
Right, but it is create pool specifying admin. So at that point, anyone can create pool. I think you need to clarify a little bit. Yeah.
Mm-hmm. Yeah,
Right, so
anyone can create the pool and specify anyone as admin.
exactly. So that is that function interface correct then? I'm a bit confused.
Over here?
Yeah.
No, yeah.
Oh, you mean taking the message sender, or you have to, you can specify any? Can you quote?
This one you can specify anyone currently. So this is not a
Yeah.
correct function signature yet.
Yeah, and can you qualify it with which contract we are talking about, right? So because update member is part of a pool, create a pool is part of a token, right? So I think I was a little bit, I was checking out the code in parallel and trying to find out where the code is. Yeah, so I remember yeah. So
That's
basically,
true.
Wait, is create pool is part of GDA interface, right?
yeah, anyone can create. Yeah.
So some of the functions, that's a good point that Mia brought up. Some of the functions here are in two different contracts now. So create pool is GDA. Let me see if I can find GDA. And this is pool. I'll just put P anyway.
Yeah.
Okay, wait.
Yeah, I guess I wouldn't call it the admin function by that point, right? So it's really the initial function, let's call it, but we can fix later.
Yeah, that's true. And then this is P. So these two functions are on GDA and these two are on the pool. And actually, I guess you don't even have to be considered a member. And I guess the definition of a member should be someone with more than 0 units, but anyone can connect to a pool or disconnect. And I think you can also call claim, even if you have nothing, it just doesn't do anything, I'm pretty sure.
So you can connect before having units?
Yep.
Oh, that's interesting.
I think it's the same in the IDA. You can approve a subscription even if you have no units assigned. Just nothing happens, right? Because the distributions are dependent on the number of units you have.
It may be down to too much detail, but just want to mention at least that connect pool, you have to specify address, which I think it should be a little bit more clear about function signature, a bit too loose here. So you're actually connecting a pool address, and that cannot be any address. So there is maybe worth mentioning the design principle that all the pool are registered to avoid security issue, right? So you can't just connect an arbitrary address, and the pool has to be
exactly. When you create a pool, that's registered in the super token contract, and whenever you disconnect from a pool, then you're going to be passing in the pool address. And if it's not a pool that was created through our trusted GDA, then this will just not work. This is kind of why when you asked earlier about the creating your own custom pool, it's not going to work because it requires this function to be called in GDA, and this does a very specific proxy and points to the canonical beacon contract.
Yeah, perhaps in the future we can discuss our extension points through NFTs corresponding to the pool as opposed to changing the contract itself, right? So that's another way to extending stuff, but not for now, the topic. What I want to say. Yeah, by the virtue of EVM, the pool edges are, can only be determined by the contract itself, right? So you can't, I think it's a trivial thing to mention, but worth to highlight anyway. Maybe some people don't know about the EVM mechanism. So the pool is created by the GDA itself, Hence, those addresses are uniquely dependent on, not uniquely, but dependent on the address of the GDA itself. So it's unique.
Yep.
GDA proxy itself.
Mhm.
Functions. Okay. And then these are just functions that once again anyone can call. I guess create pool belongs here because anyone can call these. So real-time balance of this works the same as IDA. If you're connected to the pool, it'll count the distributed balance as well as any dynamically streamed balance. If you're not connected, it doesn't count either your distribution received so far or the dynamically streamed balance. We also have distribute function. So in IDA, that's update index or distribute. And the difference is that anyone can distribute to a pool, not only the publisher in the IDA. We should probably revisit this in like the third session about security, but I don't think there's any issue with that. And finally, we have distribute flow. There's no equivalent here. You can basically distribute a flow to all of the members in the pool, which have units. And the pool adjustment flow rate, just as a refresher, is when the flow rate cannot be divided evenly by the number of total units. And this currently always just goes back to the admin. And an very simple example is like, let's say you have a flow rate, you want to do a flow rate of 100 and you want to give it to 9 units. You can't divide that, or is it? Yeah, I can't divide that evenly. And there's one remaining you have to send back to the admin for counting purposes. Yeah, I'll continue. And so a very happy path of how this would work. So Alice would create a pool, let's call it P. Alice can grant Bob and Carol 100 units each in pool P. Bob decides to connect to pool P because he knows how pools work. Dan is a philanthropist and decides to just distribute 1,000 USDCX to pool P. So Bob would receive 500 at this point, and then 500 would be in the pool for Carol to claim later.
Wouldn't the philanthropist be named Phil?
Okay, that's I should have done that, damn it. Alice then does a distribute flow at 100 USDCX a month to pool P, or 0. Blah 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 per second. And Carol notices that she has 600 USDCX of claimable balance of pool P and then executes a claim. So this is like a very basic happy path. So someone creates a pool as the admin themselves. Let's say Alice creates a pool where she is the admin. She can grant units to the different members that she wants to add. And then these members can choose to connect, disconnect, connect, disconnect as many times as they want. Anyone can come in and do a distribution, either distribute or distribute flow. And if you're not connected, you can claim your unclaimed balance that is locked in the pool, or in the pool, locked, but yeah. So let's go over an implementation overview. Just to go over the happy path to see what happens at a high level. It'll make things clearer, I think. So our happy path started with Alice creating a pool. And basically, when a pool is created, we use this deployer library to deploy.
Still see your, sorry, Vincent, still see the presentation.
Okay, my bad. Sec. Stop sharing. You see this, the code?
Yeah, no, thank you.
So when you create a pool, we use the Superfluid deployer library. We pass in the beacon, contract address, the admin, and the token for that pool. So another thing to note is that each pool can only handle distributions for one super token. It's not multiple currently.
This can you briefly explain? It's super. Okay, this is specific pool deploy. Okay.
Mhm. Yeah, so we're just deploying a new beacon proxy and passing the beacon contract. So this is something that's immutable in GDA. And we also have some initialized call data, which gets called when this proxy is deployed, basically initializing the pool with the admin and the token. I'm also no zero address admin. Probably should also do like no zero address token as well. I see this. Well, I don't know what would happen if you did that, but I guess this would just revert immediately. Doesn't matter.
I guess it's the same as any other non-existent address.
Sorry.
I guess it would be the same as any other bad
Yeah.
address.
Yeah, exactly. If they don't have this function, then it'll just revert. If
Yeah,
they do, yeah.
Or do we want to make that explicit so it's easier to debug?
Yeah, we can. Just put that, let's say like. I'm now wondering if it's weird if, no, yeah, I think even if someone puts their own malicious super token, it doesn't matter because it's just for that super token thing. Yeah. Particular thing. Right. So we do a mint here. We tried to do a mint of the NFT. It might not work. It should, but let's say it doesn't work. Then we catch only if it's out of gas. And we also emit this pool created event. Okay, I'm gonna continue. So once Alice has created that pool, she wants to basically give some units to Bob and Carol. She comes over here and calls update member. And we immediately check if the caller of this function is the admin. And if not, we just revert. Call this function. Here we check whether the member that they want to assign units to is a pool. And basically, one invariant is that you can't give pools units. That should be guarded against in the transfer as well. Yeah, I mean, it calls update member, so. Yep, and the member address also can't be the zero address.
You, sorry, what? You can't give units to pools?
You can't give units to pools, yeah.
We don't support chained pool yet.
Would
for now.
anything bad happen, or is it just precaution?
It doesn't support it, but the pool itself cannot subscribe to the previous pool, right? So there are a couple of design issues need to be go over.
Yeah, you can't connect, you can never connect, so you never can claim the units. And if you're a pool.
So it's like sending tokens to the token contract.
Yeah, kind of.
Yeah, well.
No way.
Yeah, well, so for this version, no. I think when we were doing some of the predecessor of GDA design was called who's to remember? CFA? Oh no, FDA.
Yeah.
FDA. But there was some people suggesting the indirection, level 1, level 2, level 3, whatever was it, indirection, right? So that's effectively means chained pool per se. So you have one pool distribute to other pools. It is possible actually did something in the semantic mining library that I mean, but but I think it's not worth it for now.
Thinking of use cases, is there anything specifically that we would unlock if we were to do
It's a
this?
design surface thing, right? So we can't imagine all the use cases, but one of the use cases was actually mentioned by the person that did a different way of imagining how. So it's in the FDA was. So I think that was for. I think the use case was that you have one, let's say, currency exchange rate at level 1, then you have another level which is multi-assets, right? So then you can index to the currency exchange rate while you have exchange rate between other assets in the second level. So let's say imagine that you have a main portfolio, which is in euro or in Swedish krona, and then you have an exchange which is investing that, let's say, US dollar assets, right? So you have this 2-level indirection already. So one level changes affects all other prices, but maybe the prices in US didn't really change, but the Swedish krona price changed, right? So that kind of indirection was one of the cases if you wanted to do this kind of multi-level, translating one asset price to the other with one level indirection. That was one of the use cases, but it's pretty DeFi heavy use case. I'm sure there's other use cases also, and as part of the design surface principle, you don't know what you don't know, and can't really answer all the questions. Ideas. If we can afford it, we increase the surface so that some people can figure out something.
Yeah. I mean, I was just curious if someone asked for it, because then it might be an indication that it should be something to consider.
I guess the people asking for it at this point are more like, okay, if you think about all the possibilities, you can easily come up with ways how to use it, but that doesn't mean that it's necessarily worth the complexity to go there.
Yeah, just because you can build it, I mean, it's a good idea, right? It doesn't have to be that.
Yeah.
But my question was more pointing towards, okay, even if it's not per se supported, do we even care about prohibiting it? It's a bit like if you make a token contract, do you prefer to keep it minimal and allow this kind of user error?
Yeah, well,
not?
that answer is easy because it does come with the extra logic you need to implement, and so it doesn't come for free, right? So that's why I want to qualify the things as we want more design surface at what cost, right? So I think a V1 structure is probably a bit cumbersome to support too many features, but some of the new formulation I thought of could probably increase the design surface without being too costly. And for this particular formulation, I think the cost probably is too much. I don't know, how to say if we don't have a prototype, right? But I have it in semantic manual. One day we can talk about that instead. Maybe let's back to things and stuff.
Yep, no problem. So the update member, basically you just get the time from the host right at first. That's just blocked out timestamp, but in the future maybe that's something else. There's a lot of wrapping and unwrapping that needs to be done because the semantic money library uses custom defined types. And then earlier I was mentioning that we have some interfacing that needs to be done between the contracts here and then the semantic money library. And this basically just converts it into the correct type of wrapping, turning it into a wrapped particle, which is just a bunch of wrapping. So, and this. Yep.
Yeah, wait. So this one is didn't do the safe cast, right?
Yes, it is safe casted. If it's upcasted, it's always going to be safe. And then we do a .2 int 256 and then 2 int 128. So converting it to ints is what requires a bit of extra.
Yeah, so upcast. Okay, yeah, that's indeed. So yeah, in the CFA code base, we even for all the upcast, then downcast case, we make both comments, right? So for here, I would recommend actually, maybe this particular code appear multiple times, I would say, if I'm guessing correctly. So you could have a utility function that converts from this semantic money into, converts from uint 128 to the semantic money unit, right? So one function, so that you can make extensive comments there, so repeating everywhere. So extensive comments would be because this one is upcasting and this one is unsafe cast, and it is okay because we know it is okay, right? By just locally observe that. That should be, then you don't need to repeat that comments. You don't write it in this. Yeah. You really like that kind of long function name?
This is just a placeholder for now.
Yeah, that's fine. That's fine. Yeah. So then you just need to make one time the comments, right? So that definitely raise eyebrows, right? So just because it's unsafe downcast and so it doesn't have code checking.
I'll replace. Okay. And yeah, so there's interfacing that needs to be done between semantic money and this, and we have a bunch of helper functions to help with that. So I'll probably also look through and apply this same pattern. Will make the auditor's job easier, I think. Let's see. So if the member is not connected to the pool, we do a claim for them. This is similar to the IDA as well. So if you update units, subscription, or update units for a person who's already got units or got something to claim, we shift the balances in IDA. And then we also update the pool's disconnected units.
Why do we do the claim?
It's the same as IDA, I'm pretty sure. So if you already have units in or claimable balance for this pool, and we're updating your units, let's say to 0 or something, we help you claim that before the units are actually updated.
Is that because it makes our accounting easier, or because we think the user appreciates that?
I think that it probably makes the accounting easier. If I have to guess.
What do you mean by making accounting easier? What does it mean?
Like, why do we claim before we update the actual units of the member?
Why do we
I think
the order doesn't really matter. So the library usage doesn't require you to do that.
yeah.
So you wouldn't have to claim in order for it to work?
No, the order doesn't matter. But as Coleman said, it's a trigger side effects. Yeah. So the order really don't matter.
I don't mean the order.
Is...
So can you remove the claim here and not claim?
You can, but as Coleman said, it is as a trigger side effects, right? So that the it's the same as in IDA. There's some side effects triggered, right? When you update units, so even if you're not connected, you get those distributed because the assumption is that you would like to have a balance whenever you want. But if you don't want to connect to it, or in the IDA's language, if you don't want to subscribe to the index, then the only moment that they can trigger is when something related to your account, some events related to your accounts happens and would trigger side effects for you. So the assumption is that having some balance in your account is better than not, right? But of course, I can find some edge cases where you don't want, for example, you don't want that account to have balance so that your stream doesn't get extra liquidity when it doesn't have to, right? So let's say if I want to keep my let me use an analogy, right? So I have let's say I have a pocket money, but I don't necessarily want my pocket money have like some trigger side effects. Something happens that my pocket money gets more, but the whole point of have pocket money is I don't have too much money in it, and so that I don't have this case that I run out of money. Sorry, I got more money stolen than I wanted. Like that's one way to put it. But that's kind of the contrived case I'm trying to find. If that answers you. It was basically assuming that having is better than not having.
It seems has a slight smell because it's a bit surprising because the function signature doesn't suggest that it also implies a claim.
Yeah, it is. It is surprising in a way that kind of copied the ideas kind of a mental model, right? If you want to make more comments, Vincent, go ahead and elaborate a bit more.
Yeah, I can.
And if you could update memories.
Remember, sorry.
I'll call it.
Okay. So then we have here. It's called in a bunch of places, but the interfacing, converting the types, and then once we like I said, most of the logic is abstracted away to the library. I'm not going to go over the library stuff, but I think settle just updates the balance considering the flow rate and everything else given the current time. And we're just adding the shifted units, and this can be negative, I believe. Yeah, this can be negative. And then adding claimed amount to settled value. And updating the disconnected members in the pool state as well. So this is just an accounting function, basically. Then lastly, this is the block of code that actually updates the pool members units. There's a pool member update function in semantic money, like it's called. We update the index, which is returned from this function. We also update the PD pool member to member data, or I guess the member data from this function as well. And
this one is packed storage definition, right? What is the definition of?
It's a struct. Yeah.
Right. So we don't have any conversion function because we trust that it's packed. Do we have a layout, struct layout validation function somewhere? So I mean, test case, like what we do in the other code, because this is also important to CI validate over time, because easily you can swap it and without noticing everything still works in the isolated text, but once you go to production, everything all hell break loose, right? So I
No,
would,
yeah.
yeah, so make sure that the storage layout order is tested, and here we do assume that it is API packed, encoding packed, which yeah, I'll find a reference to actually guarantee that in the documentation from Solidity, but it's always stuff that make you sweat because you have a lot of assumption about the binary level stuff. That's probably one of the reason I would do handmade bit operation, so that I kind of remove the underlying assumption. But if you do want the underlying assumption, but do test it. So
what are those assumptions?
The assumption is that the Solidity compiler will help you pack this. So if we did something like this is less efficient because it's going to be
Okay.
256, 256, 256. But if we have all these together, it's 256 and 256.
yeah, I mean, there's a lot of assumption there already, right? So first of all, the API encoding scheme is stable, and they are tightly packed. All those. How do you construct this one again? You can go back to the previous code. Is that directly from the semantic money, or did you do conversion? Can't remember.
Yeah, there's a conversion.
Okay.
Here.
Okay. Yeah. So you do the conversion and yeah. Right. Okay. All right. That's fine. Yeah. I think I don't have too much comment about gas efficiency, because half hour ago you just added one if else without without questioning it. So, but I do have a comment about ABI stability, right? So that part can bite you even much harder than the gas stuff. I think it's trivial, but the bitstream compatibility is very problematic. Okay. So our assumption is this Solidity packs it in a deterministic way, which is a reasonable assumption, and the ABI is stable, the same as the ABI encoding one from Solidity. I think that's a reasonable assumption, but let it be.
Yeah, and the alternative would just be to use an arbitrary, memory, right?
Alternative is hard code, handcraft the construction of the data. So there's deserialization in the byte stream level, handcrafted. So that you remove the underlying assumption altogether, and that's what's at least in CFA case. But in CFA case, there was more inevitable, because data was stored through the more primitive APIs, like stored data at word 1, word 2, word 3, this kind of API. So that will kind of, unfortunately, have to do like that. In this case, because we don't use that API because it's pool, I think now we're basically saying that we just store as it is according to this struct. It is fine.
Yeah, we still have some of the custom hacking in the GDA whenever we're storing it in the token, because that's the only way to do it with the token.
Yeah. That's just the legacy storage access API. Unfortunately,
So Yeah, this basically updates members, data in storage in the pool and also in the index data in the pool. And we also call this function in the GDA. And yeah, this is also a bunch of stuff that gets abstracted to semantic money. But we're basically updating the universal index of the pool and storing that in the token contract, and we're setting the pool adjustment flow rate for this pool. Also in the super token.
Okay, so one thing that we gloss over that I myself missed is when does a function trigger callbacks, right? Because that's a control flow hidden behind that token monad thing, right? We're not there yet, we're in the pool only. Does pool have callbacks?
You mean like
not?
these functions or like do flow?
Yeah, but yeah, no, probably not.
Not directly, but I guess through functions like this. Yes.
Append index update by pool, but that's calling the GDA, right? So yeah, that's clear. Yeah, well, sorry, I jumped ahead. I think that when we look at a GDA implementation, then we will have to be really careful that if the function can trigger callbacks, which I think the function name is encoded as do. So when you see a do function, that's where your alarm should be triggered, that do.
Yeah. So there's a few
callbacks
of these do functions in the token monad that I guess do have state altering effects.
Yeah, but that's not in the Superfluid pool implement. That's in the GDA, right?
Yeah,
that's fine. Yeah. I jumped ahead. Yeah, sorry. Go ahead.
All good. So after we update the pool members units, we emit this event, super token member address, new units, and we mint or burn the NFT. This is just minting or burning. This is the same pattern as the CFA, except everything happens in one function. So yeah, basically handle the delete case, the create case, and the update case here. Okay, let me just double check what the happy path was. Okay, let's say now that Bob wants to connect to the pool. So Bob comes over here, passes in the pool we just created, and wants to connect to this pool. And this is going to be 0x. So this connect pool function is also done via call agreement, and which is why we have this. I have to return this as well. And if the member is not connected, and we do all this before going to there, how we do this authorized token access, which is needed for all call agreement functions. And let's say they want to connect. So we run this code block. We do an assert that the operator connect member passing the sender from context, passing true and the current time. Let's see what this does. Okay, so this basically just shifts the whatever units that the member had that was disconnected to connected, or removes them from the disconnected member's state. So the Superfluid pool has like a state for specifically for the disconnected members as well. And there's also for each member as well.
And for the disconnected members, like, is there any specific reason we need to track that?
I think it's mainly for just for view functions, if I understand correctly.
Also for some utility function like get total disconnect. So when you go to the pools interface, you know, oh, how many of those money are go to disconnected member, how much are going to the disconnected member. So it's a clear linear time calculation.
Makes sense.
Yeah, so I always like to visualize it as the pool is literally a pool, like a tank, and there are distributed money to it, and there are pool members taking, you know, liquid from the pool, taking liquid superfluid from the pool. The tank level will go up if not all of the members are subscribing, are connected to it. Yeah, you can visualize like that.
Yeah, so there's a separation between connected and disconnected. So you'll have getting the disconnected balance, flow rate. Yeah, might be helpful for developers.
You do a basic reminding of everyone, actually including me. Do we allow multi-distributor in this
Yep.
case?
There's
Great.
multiple people who can distribute to the pool that are not admin. So yeah, anyone can distribute to the pool.
Yeah, that's convenient.
So if the previously I mentioned that we do also want to ensure that this pool is actually registered in our protocol, and that's what this does, kind of. Or no, this is okay. This is for just the member themselves, stating that they are now connected to this pool. So when we iterate over their agreement or over the pools for the real-time balance function for GDA, we can actually see their dynamic pool balances. So this is using the exact same pattern as IDA, where we find and fill before it was slots bitmap connection. Yeah. And we just create this agreement here for the pool member and pool. And in the disconnect case, it's, you know, the opposite. You terminate the agreement and you just remove this connections bitmap, and they will no longer have the real-time balance counted here. Yeah, let me just quickly finish the last few and then we can do Q&A. I'll just quickly go over distribute and distribute flow, but we have some access control stuff. And as you can see, most of the stuff is just abstracted to both token monad and also semantic money. But in this case, it's mostly token monad.
Yeah, I think the worth maybe highlight a kind of implicit convention that when you call a do function, you have to be extra careful because do function means that it can alter the control flow. In the monad case, by the design, when you call do function, it will call the callback that you registered, right? So the callback in this case would not callback, how to say virtual function, pure.
Yeah, virtual functions.
Yeah, pure virtual functions. C++, how do you go through?
I think they're just pure function, or not pure, virtual functions. So
yeah, virtual function.
We have all these underscore set, underscore get, and these functions are implemented in the GDA itself. So, and all of these are for, you know, you just take some data, I guess this, and this is always going to be the token. And all we're doing is updating the agreement state. So this before, it's basically the exact same as CFA and IDA, where you call the function, make some changes, put into the token, and then that's the end of that. And in this case, there's no callbacks or anything in terms of super app callbacks, but there are callbacks through, I guess, token monad.
Yeah, the virtual function. So the whole point of that is how to make a reusable library, right? And because of the limitation of language, this is only kind of the most standard way of doing extensions. Reusable libraries. If you look at Open Zeppelin, there are quite many library was designed like that because that's the only language facility you have in the solid language. So you put a bunch of virtual functions, and so the control flow will be a little bit, back and forth like this, right? So it's not my favorite one, but that's the only one that's familiar to people. There's another fancy one called the token F, but it's an experiment. I didn't want to use that.
And I guess last function to run through real quick is distribute flow. Basically same thing as previously as to distribute. We're calling this do distribute flow via pool. This is a function defined in token monad. It's a bit more involved. I'm not gonna go over it now. I think that's probably for the next session.
Yeah, I think when we talk about adjustment flow, that's where we can find the time to go over that again. So that might be a design decision that we can at least document it, if not change it.
And then we can also, or we also have this handle distribute flow on behalf of another individual. So this is for liquidations. We don't have ACL currently, so this is just for liquidation. So if you send greater than 0, then we just revert because that's not something we're supporting right now. And then this is the liquidation case. This uses the exact same logic as CFA. I'm not gonna dive super into it right now. And this is because of stack too deep. And yeah, we only allow this if middle bounds less than 0. Otherwise, we just revert. It's non-critical sender. This adjust buffer handles the buffer or setting or reducing of the buffer depending on the previous flow rate and the actual current flow rate that gets distributed to this pool. We also need to ensure that the sender has enough balance to execute the transaction. Let's say they don't have enough balance because of the buffer, then this just reverts. And this is the minting and burning of the NFT.
Can you go back to this gas check? What is this?
This one?
Yeah.
This is to check if the sender has enough balance to execute this transaction. So if you specify too high of a flow rate and you don't have enough buffer to put up, then it should revert. Basically.
Okay.
And this is the NFT logic. So mint, burn, and update on create, update, delete, because this one function distribute flow handles creation, update, and deletion. Unlike the CFA, which has create, flow, update, flow, delete, flow.
So regarding that ACL part of comments, can you go back? Let me pause a little bit there. Request flow rate, sender. What is from?
From is the distributor.
Distributor. I thought you said we support multi-distributor.
Yeah, anyone can call this function.
Yeah, so if it's not, oh, sorry, yeah, the when the from is not equal to the message sender.
Of the context.
Okay, so but I will put a lot of interface anyway.
How messy would it be to share the ACL permissions with CFA?
Very messy.
Yeah, I don't.
We didn't make it a library.
Yeah.
Logic, yeah, library share is not easy. You have to find a proper way of doing it. There's If it's stateless, that's kind of slightly easier. You just use pure functions everywhere, then you have a stateless sharing. But for the ACL logic, it's actually not stateless. It's quite stateful.
Need like a module for that ACL module that they both.
Yeah, so something a bit more ERC-777 like maybe.
I think the groundbreaking chain ACL improvement in CFA on tangent track, on a tangent say that. So would be approval with time components. So currently approval is this discrete number, right? So a better alternative is we approve with time components also, so that the approval amount is over time going up or down.
But wait,
Continuous.
isn't that what flow rate is?
Flow rate is, but the approve is not. Approve allowance of the function of time. Allowance is a fixed number. Right. So
Yeah.
the allowance can be functionalized, reactivate. Yeah, make it reactive to time. If you're interested, we can do someday spare time do the semantic money version of it, because it's quite trivial, because you can reuse in the same library, because it's the same. Basically it's the same as flow rate operations as for allowance. So you can consider allowance as anti-balance or something. I see. In a way, it's a kind of same formula down on the hood.
Yeah, ACL is definitely an interesting topic.
Well, let's move on. So we kind of, in a way, we keep the ACL interface in, but we just don't support it, right?
There's no ACL interface in GDA currently.
Well, I mean the potential.
Yeah, potential. Yeah.
Yeah, but from what's the function name again for this distribute flow? That's already leaf level function. So there's a from. So you're forced to set to the same as your message sender, right?
Yeah,
Okay.
currently. Yeah.
Is that how CFA interface is? I don't think so.
No,
CFA
because CFA has create flow, update flow, and delete flow separately. We needed the from also to handle the liquidation case.
Yeah, I meant in CFA you have a create flow by operator, right?
Yeah, exactly.
Yeah, so this one's kind of unified in one, although it's not supported.
No.
Okay, got it. Yeah.
Yeah, because this has to also handle deletion.
Yeah.
And yeah, we just emit this event here. That's pretty much it for this. And I think claim, I think I went over claim already. I don't remember. But yeah, this is fairly straightforward. We just do some functions in the GDA and then shift the disconnected units. Yeah, we can jump into the actual implementation details next time, but I think this is a good point for questions. So
Has anybody brought up the question about permissionless claiming even being desirable?
permissionless claim.
I mean, I think we have discussed this before, that in theory, it doesn't matter if you claimed or not, it's just internal shifting, but who knows, funny legislations may come up with different text rules depending on did you claim or not.
Right.
In
I
that
guess
case, permissionless.
Yeah, I see what you're saying. Like if someone else claims for you, but you maybe didn't want to do it yet, and then now you have to pay taxes or something.
Yeah, I'm not sure if this is an objection which is more than theoretical, but one I could think of.
Just don't connect your address to a real KYC. I don't know.
It was one of the goals of 777 that you could take control of that via the hooks. For example, say I do not want to accept this or that tokens, or yeah, stuff like that.
Mm, mhm. Makes
But
sense.
I don't think it's super important now. Can I also comment on the API thing I wanted to mention?
Yeah.
Update member. It seems to me that this function signature isn't ideal, because it's what's actually changing is the unit. So I feel like update member units or set member units may be more
Mhm.
self-explanatory.
I think that makes sense. Yeah. Update member. I guess, yeah, it's like, what are you updating for the member? Update the member. You're not changing the member, really. But it does show you that you're taking new units as a parameter. But yeah, I think being more explicit is
You're
probably.
not sharing screen anymore, right?
No, but I can. Let me do that. But yeah, I think update member units makes sense because it's more explicit. Doesn't hurt, I don't think. If no one has objection, I'm just gonna change it right now. Okay, I'm gonna just change it. Any other questions? Or
Yeah, I
Mhm.
have. Okay, I don't see the. We already talked about it. I don't see the utility of having an NFT
Mhm.
to
Yeah.
symbolize an admin, whatever that means in the pool.
Yeah.
The code is complex. I think there is a lot of moving parts to add that with no real value on top of it. I think we should really think about having a role-based access to the pool and not an NFT one.
Mhm.
So
Yeah.
we should split the operations basically, because I want to create a pool, I want to be admin, but I want to give GD the capacity to add members to the pool.
Mhm. Yeah,
And
Isn't-
I'm not going to transfer my NFT to GD because now he's an admin to do that. So we should clear about the delegation of functionality, and I think the NFT is too narrow, too linear to do that. It's basically all or nothing with the add-on of complexity of code on top of it.
But if I may comment, I think the idea here was also to be able to hand over ownership to a contract which implements more fine-grained
You don't need the
separation of roles.
NFT.
Is that possible with this, Vincent?
hand over ownership of the contract, Superfluid pool contract.
So
or-
to say I want one guy to be able to just increment units and another guy, I don't know, be able to reset units and have a custom contract which can do that, and then say and then set this contract as the pool admin.
Yeah, currently that's not possible. The admin is static. It's set during the,
So it's not transferable.
no, it's not transferable.
Okay, but it shouldn't be too difficult to achieve that, right?
Transferring admin ownership, yeah.
Yeah.
It's just tough, like function.
But I think that was the idea behind this construct.
Yeah, but I would argue that we are making more complex, adding the NFT concept.
Yeah, that was kind of how can I say, kind of a design decision back then that we want to
Could
use
be
721 and 20 interfaces where it makes sense.
could be I think it's going to be
Sure,
more ergonomic if instead of you deploying an extra contract as in the NFT, when you deploy a pool, the pool is already a contract. You don't need another contract to do that. Basically, it has the delegation systems already inside. Using the NFT could be just basically, okay, we want to use it, but the utility is going to be always pretty narrow.
Yeah, but this comes down to the limitation I mentioned before. So I realized after saying that, so we now only have this canonical implementation. You cannot pick or customize your pool contract. However, if the ownership can be handed over, then a lot of the additional design surface becomes unlocked by saying, okay, I implement a contract. It's a bit like the operators in 777. I implement a contract with the permissioning I want, and I make that one the admin. I think this combination is pretty powerful.
So update the admin, handover admin is doable, right? It's a simple. There is a transfer admin. I see that. I see in my face here. There is a transfer admin.
So it's just
I just
it's
added
just the NFT not being.
Oh, you just added
Runtime.
sneaky bastard.
But he asked for it. I'm just saying it's very simple to do, obviously, but yeah.
Okay, so
This is actually wrong because we also need to like transfer the NFT.
So the question is more about, is the NFT worth it? Because this could also just be a custom transfer function, right?
I also think that the utility of the NFTs, like now that we've seen it semi-live, at least from UDI side, because the existing NFT gating infrastructure doesn't really support our NFTs, and like it's pretty customized. I'm not sure if the utility is worth like the gas cost and the additional complexity and just extra code for auditors to read and reason about.
Yeah, it seems to me that that we are not hands-on enough with NFT stuff to even understand what the state of ecosystem support is. Because in theory, it seems like a great idea, but then you realize, oh, there's these strange processes to even get it into OpenSea, for example. And then the question is, okay, but what's even the point of having it listed in OpenSea? You should have it in the wallet. So in the wallet, you can trigger the transfer, but on the other hand, we don't yet have to transfer. And it's also not clear which wallets will even show it, because they may query the OpenSea API, and it's all a bit, I don't know, a bit strange, confusing. So I have become a bit disillusioned about the value of adding the NFT interface, to be honest.
Yeah, I think the original idea of being able to transfer it, that definitely has more utility. So you can transfer your streams now that they're NFTs.
Yeah, but also only if it really improves UX automatically, because if you need to jump through hoops, etc., to even get it into your wallet, then you can as well go to a custom dApp, connect your wallet, and call the custom function.
Yeah, true. Good point.
Would NFT ever come back?
Sorry,
You mean the NFT?
Of course,
I don't know, why are you laughing?
Because of course,
I mean, if even if the NFT hype does come back, I don't think that I'm like not sure how this would actually add value, other than maybe marketing value. Which
maybe the NFT API is currently too married to JPEGs. I could imagine that if eventually a bit more interesting, I mean, that's a subjective thing, more, let's say, more sophisticated use cases start adopting it, and tooling around it doesn't assume it's about JPEGs, then maybe it would become more useful to integrate that. But And kind of with Nuno here, that it's questionable if it's even worth it at this point to care about it.
Yeah, I think one of the main use cases that people were thinking of as well was using NFTs as something to like token gate or but is that
true.
most
But
of
for the admin, I know it's for the admin that's
the admin NFT and then the pool member NFTs, I think we could do without personally as well.
Pool members maybe, but then with the pool members you have this other problem that we cannot emit the events, and so it may not work again in many cases.
Cannot emit events. You mean, what do you mean?
Well, there will be an event if you are added as a member. Well, okay, you have that event. You don't have an event if you get a new stream by a pool.
No, there's no flow distribution event. So
but we still haven't done the ERC20 part of the pool.
no, we have. This is
Good.
is IRC20.
Yeah, great. Yeah, that's more useful.
Yeah, this
Dividend share distribution. Share transfer.
Yeah. I mean, because I think the problem is also like if you want to make them useful, I think they would have to be customizable, and that's not going to be able. I mean, we're not going to be able to provide that. So unless that's will be possible, I also think it's going to be a limited value. Because I mean,
sorry, just briefly, what we could easily make customizable is what the token URI returns. So basically visualization, because that has no effect on chain operations.
I mean, takes another block, for example, they could, like, if that was possible, I mean, they could, like, if you could customize metadata, I think, like, they could basically replace everything with just, I mean, the pool members being, I mean, each pool member being an NFT, right? So that would represent all of their music holders, all of the music rights, the NFTs that they emit themselves today.
Yeah, I think worth gathering a little bit of intel. I think those are low-hanging fruit, simple extension we can do, such as customizable metadata that based on the member as input, right? So you can customize URL per member and perhaps transfer anything. I don't know if that's useful, probably not much. Yeah, I think metadata customizability is good. Perhaps people even would ask that the ERC20 non-transferability of the units. Currently, it's by default, you can't turn it off, right? Imagine people actually use it for the representing the share of the company or something.
Exactly.
Sometimes you don't really want unregistered transferring of shares. Okay. But it's fine.
That's where my reasoning was going about allowing not only the default implementation, but I think specific use cases like this can be made possible with maybe not arbitrary hooks, but some kind of configurability. Maybe
configurability. Yeah, configurability is sometimes sufficient for that. Hooks is a dangerous one.
Yeah, I guess
but I think the transferability of ownership of the admin role is, I think, cheap and important. And NFT, if it's already there, I think leave it. But
yeah, I know that Nuno's point is that it makes code more complex, but it is really about how to manage complexity, I guess. If more lines means more complex, then we'd rather not even do anything. But in this case, add the value is also questionable, I guess, transferable NFT over the pool. Yeah, I think the value would be really about the customizable metadata. That's probably make the NFT more, seems one more usability, right? So another block or whatever project use that can customize their pool members visualization assets might be useful for us.
Hmm.
Okay, another thing is basically if we can emit a transfer event when there is a distribution to the pool. I know the IDA doesn't do it, but I think we should emit a RC20 transfer just to signal because the user is sending tokens, RC20 tokens from one account to the pool, and we should signal that. We know that we cannot do that to all the subscribers or to all the connected members, but funding the pool, I think we should have an event. Discussable, but yeah. And also going with the claimable permissionless. So we are creating a system that I can create and force Vincent to be admin in 1 million pools, because I can basically deploy any pool with another admin.
Then you can go to the SEC and say Vincent is issuing unregistered.
Yeah, I was thinking about it. That's why I also don't really like the transfer of even CFA by NFT, because Vincent is sending me money and I'm going to send money to Tornado Cash. So now Vincent is sending money to Tornado Cash.
Exactly. And you can actually currently transfer units to Tornado Cash as well.
Yeah.
So
Yeah, but then Nuno, I can also deploy Nuno coin and transfer ownership to you. So
yeah,
sure.
I think,
no,
I think
yes, it's true. But in here we have a different part, because when you do a distribution and there is an adjustment, you are sending to the admin. So now that admin is touching the balance.
yeah. Vincent, have you finished? Is it on schedule? Because we just finished the time.
yeah, but if we can continue, if you guys want.
Okay. I think it's good here. I just want to say that on a tangent, funny thing is that I think nowadays it's harder and harder for you to be able to give the company ownership to anyone else, apart from probably only the English system would remotely possible allow that. I don't think continental system ever allow that. Right, so it's the same here. It's like you can transfer the ownership without, you just send an envelope, say I signed it, and now you're the company owner. You can just send it, give it. I think English system used to allow that, but now there's so many international framework. I don't think it's possible anymore. But blockchain made it possible again.
Yeah.
So Nuno, you can finally create that turtle company. No, what was it? The Final Fantasy, the
Shinra Corporation. That's my dream.
Just transfer to Vincent and send a letter to SEC.
Let's DOS the SEC.